Hello everybody. Alright, so this is the video for section 6.6, which is another application of the trigonometry that we've learned, and this deals with complex numbers. So first of all, we need to know what a complex number is, and I think we've kind of talked about that before. You've got the real numbers and the non-real numbers, the numbers with I in it and things like that, the imaginary numbers, and we put those all together and we call those complex numbers. So usually we'll write a complex number as 5 plus 3i, or negative 7 plus 6i, or just in general a plus bi. So it's going to have that real number part, and then it's going to have this imaginary number part. So you got a real number and you got an imaginary number, and you put those together and you have a complex number. So where does the trigonometry come in? It seems kind of a weird application for trigonometry. Well, when we normally plot a set of ordered pairs on the Cartesian coordinate plane, we have an x-axis and we have a y-axis, and both of those axes are real number lines, meaning that you only find real numbers on them. So it would be impossible for us to plot a number like negative 7 plus 6i on a coordinate plane that only has real numbers on it, because obviously we have a non-real part here. So what we do instead is that we devise this thing called the complex coordinate plane. So this is the complex plane. And so on the horizontal axis, we used to call it the x-axis, but it's not x anymore. This is just the horizontal axis. That is now called our real axis. And then the vertical axis, we used to call it the y-axis, but the vertical axis is the imaginary axis. So all the i's are on the imaginary axis. So let's plot the number 5 plus 3i on our complex coordinate plane. Since the real part is 5, we're going to go over a distance of 5, and I just realized that I probably should have used like each square was worth 1, but whatever. Let's just say to there is a distance of 5. And then the imaginary part is 3i, and it's positive 3. So we would go up, and I'll go ahead and do it here. 1, 2, 3. So we would go up. Actually, I need to do it over here. 1, 2, 3. We would go up a distance of 3. And so since that's on the imaginary axis, then that distance isn't really 3. It's actually 3i. And so if we go right 5 on the real axis and up 3 on the imaginary axis, that defines a point, and that point is actually the graph of the complex number 5 plus 3i. So we actually have a way to define the location of this complex number on a coordinate plane. We just have to use a complex plane. Now once we do that, you can see that all I have to do is draw the diagonal there, and now we have an angle and we have a radius. You know, if that point was on a circle, then that would be the radius of the circle. Now, the radius of the circle will oftentimes be called the absolute value of the number. Okay? So it's the distance that number is from the center, right? So absolute value, that's what absolute value is. Normally on a real number line, absolute value is the distance from 0. On a complex plane, these points are out here in space, and so their distance from the center is the absolute value of the number. It's very common for us to give names to our complex numbers. A lot of times we use the letter z. So let's say that we define we define the number 5 plus 3i, and we'll say that that's represented by the letter z. So you can still call this r if you want to, that's okay. Just know that it's also called the absolute value. And so we represent that as the absolute value of z. So you can call it r, you can call it the absolute value of z. We also like to call it the modulus. I don't really know, well, I kind of know where that word comes from, but I understand that seems like a weird word to you, but that just means the same thing.